Okay, today starts our study of geometry. And for the rest of the year, we're going to be into geometry, so it's the exact opposite of all the stuff we've been doing in algebra. A quick description about the difference between algebra and geometry. Algebra is forward thinking. You start with a problem, you come up with the result. Geometry is thinking backwards. Here's your answer. These two shapes are congruent. You tell me why. Geometry is very important, though. The kind of professions that good geometry students would go into or could go into are some kind of detective, lawyers, things of that nature, where they have to figure stuff out and look for evidence and then make arguments. And when I say make arguments, I don't mean yelling and screaming. I mean an argument like this. You're a senior, right? James, you need to do well in this class. Take your notes, do your work, and get good grades on the test because 1, you want to grade higher than D. Because 2, you want to graduate from high school, so you need that grade higher than D to graduate from high school. And 3, you want to graduate from high school so that you can get a good job, buy stuff like the rest of us, and lead a at least moderately successful life by whatever your definition may be. So that's what I talk about when I form arguments. Juniors, 1, let's see, what would be a good argument you might want to have? Mom and Dad, you should buy me this thing because blah, 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 whatever that thing it is that you want. For this reason, I don't know, I used to use iPod. You need to buy me this iPod because I can watch Mr. Bfoutty's lessons, download them from his website, and watch the vodcast of it, or whatever BS excuse you want to use. That, of course, would be really stretching it, but your parents won't know any better if they're not very computer literate. You should say, look at this website, I can download it. You should get me that. And they might fall for it. So there. If nothing else, you get nothing else from this class. There you go. All year. All right, geometry. It's the combination of a couple Greek words. Now, when we study geometry, that's what if you get mad that we have to learn this stuff, don't blame me. There's a dead Greek guy named Euclid who came up with this. So the kind of geometry we are studying is Euclidean geometry. What? No. Are there different types? Yes. There are 3 different kinds of geometries. Euclidean, which comes from geometry. Geo is the Greek word for awesome is not the kind of word I would use. Good gas mileage, and probably not on the road anymore. Is the Greek word for earth. That's funny, though. It's the Greek word for earth. Metry, the specific translation is the measure of. The one we could also use is the study of. The study of. So, like literally the study of the earth. And when in geometry, what we're looking at is all these things can be seen on the earth. Straight lines, circles, triangles, squares, rectangles, all those things can be seen on the earth. Now, Dennis asked Euclidean, is there stuff that's not Euclidean geometry? Are there other kinds? And he was being kind of glib when he said it, but yes, actually there are. There's parabolic and hyperbolic. In parabolic geometry, a triangle looks like this and has more than 180 degrees. In hyperbolic geometry, the triangle looks like this and has less than 180 degrees. No, we're not learning that. That's high aerospace engineering, high level thinking. There's the earth, right? This is how it was crudely explained to me so that I could understand. There's the earth. In parabolic geometry, that's a straight line. So what your natural reaction was my natural reaction when I looked at that professor and said, wait, you kidding me? I can see the arc. That's not a line, it's an arc. He said, no, this is the earth. And as we look at it on the earth from there to there, it looks straight. But in space, which is 3-dimensional, and light curves and all that other stuff, that's a straight line. So that's the difference. So yes, there are other kinds. Let's get back to this kind that we all know and appreciate, all right? But thank you for the question. That was a very good question. A point. A point is a location. Oops. That's all it is. It's a location in space, if you want. It has no size and no area or dimension. And you need to think of, for the rest of the year, all this stuff. Whenever we look at a shape or something, it's floating in space. When I talk about space, there's a point, there's a point, there's a point, there's one, there. They're all over, infinite. And you can't just think about on your paper like that. That's two-dimensional. That's not how that's not the world we live in. The world we live in is three-dimensional. Plane, and I don't mean the one that flies. Now, first of all, let me show you on paper how we denote plane. It is a parallelogram. But a plane is a flat surface that never ends, so it goes on and on and on in every direction, forever. It's a flat surface with no dimension, meaning it has no width or height or length. And there are infinite numbers. Here's a plane here, here's one here, here, going horizontally, vertically, diagonally. They can intersect, all kinds of stuff. But that is a plane. And finally, the last kind of definition we need is space. Now, point and space are related to one another. Because point, that was just a location in space. Well, what's space? Space is a collection of points. Now, all these things are just called, and we'll get to it, postulates. They're just things we assume. We can't prove them, so we just, okay, that's the way it is, and we move on. We don't argue it over it. We just say, okay, that's the way things are. We accept it as that, and we go. And we can prove. We can prove other things. Why two true triangles are congruent. We can prove that. All right, any questions so far on any of the postulates or assumptions we're making? Collinear points. Let's look at the word collinear. Does anybody see a word inside of collinear? Linear. What would be the root word of linear? Thank you. Line. Line. What does the prefix co mean? No, knucklehead. I'll get back to that one. How about same? Co means same. So that means collinear points are on the same line. Very good. Coincidentally, how many points do I need to have a line? 2. 2 points determine a line. We'll call these points A and B. Do lines ever stop? Nope. What stops? Line segments. Okay, good. We'll get to that in depth on Monday. Right now we're just talking about the points. So 2 points on a line, they're called collinear. How about non-collinear points? Those would be, no, take collinear on the same line. What does non mean? Not so much, yes, not. So non-collinear points are not on the same line. Oh, did you? Okay. Not on the same line. Point A, point B, point C. Now, C is non-collinear to A and B, right? But how many points determine a line? So could I do this? Yeah. But C is still non-collinear to A and B. I do. So we have collinear on the same line, non-collinear not on the same line. Which means I could have multiple lines there I could draw. Coplanar, coplanar. Those would be, well, if collinear were on the same line, coplanar, that's right. Points on the same plane, or on the same plane. How many points do I have there? Do you think there's a reason behind that? See, this is the important part of geometry. You have to pay attention to the notation. There's a reason why I put 3 there. Why do you suppose there's the reason why I put 3 there? Very good. 3 points determine a plane. If you don't have 3 points, and technically it's 3 non-collinear points determine a plane. So really it should look like this. I should have a line between 2 of them, because it's 3 non-collinear points that determine a plane. There. What? What's mine? Oh, we're not equal, right? No, it was an alarm. It's reminding me I have to take a supplement. That needs to be taken on an empty stomach before I eat. OPP. I saw them live in concert when I was in college, Naughty by Nature. It's quite an experience. I'll tell you later. Remind me. Non-coplanar would be... Oh, man, you are on a roll now. You got it. I can't get anything past you. Not on the same plane. No. Doesn't. You have to have at least 3. Right? But you could have more. This. All right, an intersection. An intersection is a location. Oh, great, I spelled it wrong. A location where 2 lines cross. So, since it is a location, that means that location is a point. It's a point, location where 2 lines cross. All right, now the next couple of things we're going to talk about are not really definitions, but how do we use information we have in geometry. Congruent line segments. Congruent line segments have the same length, like 5 centimeters. They are not equal. Numbers are equal. If I talk about a line or a shape, they are congruent. Their areas may be the same. Area is number, right? Their lengths may be the same. A length is a number. But when I talk about a shape or a line, they are said to be congruent. The congruent symbol looks like this. It's an equal sign with the tilde mark above it. So if two lines have the same length, then they are congruent to one another. Don't tell me that two shapes are equal or that two lines are equal. I will come up behind you and flick you in your earlobes until you stop saying that. Why not? You're so good at it. No, technically, no, I don't have to show them. It can be assumed that they're there. Yeah, right. So, another thing we might have, midpoint of a line segment. So the midpoint, by definition, would be the what of that line? The midpoint would be the middle. Okay, so that we don't really need to define too much. But what do we do with it? Here, this is what we do. If by definition we know that C is the midpoint of AB, what can we say about line segments AB and BC? They are congruent. That's what we can. That's how we use it. So then, if we know we have the bisector of a segment, if we know that line segment AB is bisected by line segment CD at point E, then we can then also make a similar statement. We can say that AE is congruent to EB. Oh yeah, it would be. Go ahead, counselor. What does it you have to say? He gets bonus points. Is that what? Thank you, James. AC. So that's how we use those. And bisector means to just cut into two equal parts because the prefix bi means two. Yeah. All right. A postulate. Oh, do I need to go back? Does anybody still need that? Okay. No, we can go back. That's fine. No problem. A postulate, we mentioned this earlier, it is an assumption. There are 4 postulates from this lesson that you need to memorize. 2 of them we already mentioned. They're all on page 193 in the little purple box. And while you're looking there at page 193, I also want to mention one other thing on page 193. And since I've said that 3 times now, if I were you, I'd open my book to page 193. Quick on the draw. He's looking at what? So you see there are the 4 postulates there. Above that, if you look at the plane there, that parallelogram, that tannish looking one, there, that little squiggly symbol in the bottom left-hand corner is a capital cursive M. That's how they name planes. It's like we name points with the letters. Planes are named with capital cursive letters. That's all that means. So you can pretty much kind of ignore that somewhat unless you have to answer a question like in your homework tomorrow with a plane. So if you look on page 194, the top one, the green one is plane J. The tannish one is plane K. And then the next one down, those are planes Q and R. And the green ones are planes U and Q. So those are capital cursive letters to name them. That's all that means. All right, getting back to the postulates. There are 4 of them. I recommend you write them down. However, you may want to paraphrase these. Sorry I'm boring you. Try to be more entertaining next time. These are the point, line, and plane postulates. Postulate number 1, through any 2 points there is exactly one line. What does that mean? We talked about it already. 2 points determine a line. That's what that means. Postulate number 1, 2 points determine a line. If you have any 2 points, there a line exists between them. Postulate number 2, through any 3 non-collinear points, there's exactly one plane. 3 non-collinear points determine a plane. That's what that means. So the first 2 we've actually talked about already today. No big deal. I don't know. I don't know. I don't know. I don't know. It's good. I have no idea. So, postulate 1, 2 points determine a line. Postulate 2, 3 points determine a plane. All right, postulates 3 and 4. Postulate 3, if 2 points lie in a plane, then the line joining them lies in the plane. Now, if these next 2 don't make a lot of sense, I'll have a couple draw pictures, diagrams for you that might help. Might help. And then postulate 4, if 2 planes intersect, then their intersection is a line or forms a line. I have 2 diagrams to illustrate these points. Here are 2 planes in both of these. For postulate 3, if 2 points are in a plane, here's point A, here's point B, then the line that goes through them or connects them is also in that same plane. No. Not big on the projects. Me either. You're in the right class then. Not that you have any choice, but and then postulate 4, if 2 planes intersect, here's plane alpha, here's plane beta, their intersection forms a line right there. Don't. I'm just showing you to illustrate what it would look like. You don't have to draw it. It's right there. It's also in your book. Bottom of page 193. Letter B, that's postulate 4. That's postulate 4. Okay, your assignment.